Okay, for my second project, I wanted to do a uniform circular motion problem. So first I'm going to start with reading out the question and then we'll get started. So it states that a brand new roller coaster has been introduced at Canopy Lake Park. The coaster car is 1.5 kilograms and moves along a circular loop with a radius of 5.0 meters. So first we can write down those two knowns. So the mass equals 1.5 kilograms. And the radius is 5.0 meters. So you can write just like that. All right, so starting with part A, the question asks, if the car moves at 12 meters per second at the bottom of the loop, calculate its centripetal acceleration at that point. So that's another number that we can write down in the known section, is that at the bottom of the loop, the velocity at the bottom equals 12 meters per second. So then with part A, since you want to find the centripetal acceleration, the equation for that is A sub c equals the velocity squared over the radius. So that, since you want to find the acceleration, it's already isolated by itself, so you can just go ahead and plug the numbers in. So you can say A equals 12 squared over 5. And so ultimately that will give you an acceleration of 28.8 meters per second squared. So it'll look just like that. So then moving on to part B, the question asks, if the car slows down to 8 meters per second at the top of the loop, calculate the net force acting on the car at the loop. So that's another number that you can write down in the known section, where the velocity at the top equals 8 meters per second. Write that down here. And then to find the net force, you want to use the equation F sub c equals the mass times velocity squared over r. So Fc equals mass times velocity squared over the radius. So then since the F sub c is already isolated by itself, you can just go right ahead and plug the numbers in. So Fc equals 1.5 times 8 squared, and that will be over the radius, which is 5. And so once you do all the math out, the net force will equal 19.2 newtons. So just like that. So now moving on to part C, which is the trickier part. This says, determine the minimum speed the car must have at the top of the loop to stay on the track. So using that, you want to also use gravity. So G equals 9.8 meters per second squared. So you want to make sure you're using that in the equation. So for this equation, you want to use the force of gravity, which also equals mass times gravity. So you can say mass times gravity equals, and then you want to use pretty much the second half of the equation that we just used. So you want to use the mass times the velocity minimum squared over the radius. Just like that. And so automatically you can cancel out both of the masses, since you'd be dividing on one side. So you can cancel those out, and then it'll equal G equals V minimum squared over R. And so you want to get the velocity by itself. So you can multiply both sides by the radius. So it will be GR equals V minimum squared. And then what you have to do is you have to take both sides. You have to take the square root. So ultimately, the equation will be V minimum equals the square root of G times R. So then you can go ahead and plug the numbers right in. So the velocity equals the square root of 9.8 times 5. And so once you do all the math out, the minimum velocity will equal 7.0 meters per second. Just like that. And that was all 3 parts.